Phaser 4 is almost here, and one of the biggest changes is the new beam renderer. If you use shaders in Phaser 3, you'll notice a few breaking changes. Today, we'll migrate some Phaser 3 shaders to Phaser 4, and along the way, I'll show you the new shader workflow and some tips to make this process easier. If you haven't seen it yet, I recommend checking out the Phaser 4 shader guide. This is a comprehensive guide that walks you through creating shaders in Phaser 4. The guide will explain the core concepts and how to use shaders in the new system. You can find the Phaser 4 shader guide on the Phaser website. In order to access it, you'll need to create a free account. In Phaser 3, we use the PostFXPipeline to create custom shaders. In Phaser 4, this is now changed. Now, we use two new classes, a BaseFilterShader for our shader code, and a controller to manage our uniforms and input textures. In this tutorial, we're going to take a look at 3 examples and see how we can migrate these over to Phaser 4. In our first example, we're going to take a look at a grayscale shader, where we're going to take our existing texture and we're just going to change the color on it. In our second example, we're going to take a look at a wipe shader, and that way we can see how we can pass uniforms to the new controller class. We'll also take a look at how we can load in our fragment shader code as a separate file using the Phaser Loader plugin. In our third example, we're going to take a look at a Noice Shader, where we're going to pass an additional texture to our shader program. If you'd like to follow along, there'll be a link in the description with the starting source code for these examples. In our first example, we have a Phaser 3 scene and a custom PostFX pipeline, where that pipeline applies a grayscale shader to our main camera in our scene. Our shader, all we're doing is we're taking our original pixel color, we're mixing it with the color gray to get this grayscale effect here. So with Phaser 4, we no longer have our pipeline system. This has been replaced with a new rendering node, which is applied as a filter to our camera and our game object. So to start migrating our code over to Phaser 4, we first need to update our Phaser library version. So in our package.json, we'll want to update our Phaser library version. So at this time, we have Phaser 4 release candidate 5. After we update our library version, you'll want to do npm install, so we'll update our library version. After we do that, our game will be broken since our pipeline no longer exists. So now to migrate our custom shader and our PostFX pipeline to Phaser 4, we need to break our class here up into 2 different classes. So I'm going to copy this block of code. I'm going to comment this out so we have it for reference. Let's paste our code. So now for our first class, we want to extend our phaser, our renderer, our WebGL, our render nodes. So our render nodes, these are new to Phaser 4, and this is what's used by our renderer. From here, we want to extend the BaseFilterShader class. So let's update our class name. So we're just going to call this Grayscale Shader. Now, since we're extending a new class, we'll need to update our constructor. So instead of getting our game instance, we're going to get something called our Render Node Manager. Our Render Node Manager is the system that owns this render node that we're going to create here. And this render node, this is responsible for applying our shader to our camera or our game object or whatever we're applying it to. So for our type, this is going to be our phaser, our renderer, our WebGL, our render nodes, and then our render node manager. So now at our super call, we need to provide the name of our filter we're going to create. So this needs to be a unique ID, and our filter, this is the component that actually gets applied to our game object or our camera. And so for this, we're just going to call this grayscale. Next, we need to pass in the instance of our manager. So our manager that we received from our constructor. And now we need to provide our fragment shader code. So previously in our PostFX pipeline, we would provide our fragment shader like this. For our super call here, we can either provide our fragment shader directly through our code as a string, or we can load in our fragment shader as a file and then pass that file from our cache. For this example, we're going to pass our shader code as a string. So after we create our BaseFilterShader class, we now need to create a controller. In Phaser 4, our controller is how we can control the effects of our filter or our shader that runs. Each game object or camera should have their own controller instance for this shader that we're creating. And so this controller, this is how we can apply the same shader to multiple game objects, but then pass different parameters or uniform values to each instance. Once we jump over to our phaser scene, we'll see how we can actually use our controller. So I'm going to copy this block of code here, paste it. So now for our class, I'm going to call this Grayscale Shader Controller. So now for our class, this needs to extend our phaser, our filters, and then our controller class. So now in our constructor, we're going to receive one argument, and this is our camera. For our camera type, this will be our phaser, our cameras, our scene 2D, and then our camera. So our camera instance here that we received, this can be our main camera in our phaser scene, or this can be the camera that's now associated with our game objects. So what's new in Phaser 4 is each game object now has a camera view for rendering out that game object. That camera is responsible for applying any filters we want to that game object. And so this is how we can now pass in one of our shaders and only apply it to a single game object in our scene. And we'll see an example of this later on. So now for our code, when we call super, we just need to pass through our camera. And now we need to provide our render node ID. So this ID needs to match our ID that we provide here. So we're just going to pass in grayscale. So now at this point, we've done everything we need to do to migrate our PostFXPipeline class into our new structure for Phaser 4. Now we need to jump over to our Phaser scene and update our renderer and our camera to use our new filter. After we created our PostFXPipeline, there's two main steps we had to do to use it in our game. First, we had to add this pipeline to our Phaser renderer. After we added our pipeline there, we could then use it with our camera or our game objects to have our shader be applied to that game object. In Phaser 4, we do a similar type of pattern. First, we need to tell the Phaser renderer about our new rendering node that we just created. This would replace our step here where we added our post pipeline to our renderer. Next, we need to create a controller, which is how we're going to apply our filter to our camera or our game object. This would be the equivalent of us adding that pipeline to our camera or our game object. So now to make these changes, let's comment out our code here. So just to make sure our code's working, I'm going to go into our main.ts file. I'm going to comment out our two other Phaser scenes, since those will be broken until we do our updates. And once we remove those scenes, we should see our game show up in our browser. Now we need to add our new rendering node to our renderer. To do that, I'm going to get a reference to our renderer. I'm going to do const, we're going to do renderer, we're going to set it equal to this.renderer. And I'm just going to type this as a phaser, our renderer, our WebGL, and then our WebGL renderer. Once we have our renderer, we need to reference our render manager. So we'll do render nodes. And so this manager is responsible for all the render nodes in our game. And now on our render manager, we need to create a new node. To do this, we're going to use our add node constructor. And now we can pass in two arguments. Our first will be the unique ID of our node. So for this, we're going to call it grayscale. And so we're just going to have this ID match what we passed in our BaseFilterShader and in our controller here. So now for our second argument, we need to pass in our constructor or our custom class that we created. So this is going to be our grayscale shader class, which is our rendering node for our custom shader. Finally, before we try to add this rendering node to our renderer, we just want to make sure it doesn't exist first. To add that safeguard, we'll do if not our renderer. We can grab our rendering manager, and we can use the hasNode method and provide the unique ID of one of our rendering nodes. And if it doesn't exist, then we'll add it to our rendering manager. And so this is useful because our renderer, this is something that's global to our Phaser game, and so it's going to be the same instance across all of our scenes. And so if we stop and restart our Phaser scenes, we don't want to try to re-add this rendering node if it already exists. Finally, we just need to apply our filter to our game object or our camera. So in Phaser 4, there's 3 steps we need to do. First, we need to enable filters on whichever game object that we want to apply our filter to. We then need to create a controller for that filter, and then add that controller to our game object. When we want to apply our filter or our shader to our main camera, we don't need to enable filters manually, and this is because these are already enabled by default. As an example, if I wanted to apply a filter to my image game object here, I would need to call the enable filters method. So by default, our filters object does not exist on our normal game objects. We have to call this method first before we can apply those filters or shaders to that object. This is if we want to apply our filter or shader to our main camera, our filters object will already exist. So if I do this.cameras, we'll do our main camera, we'll see we already have our filters property, and so this is our object for us to apply that filter. So after we enable our filters, we need to create a controller instance that we can pass to our filter. So we're just going to do const, we're going to do a grayscale controller, we're going to set equal to a new grayscale controller instance. So now for our controller, we need to pass in a reference to our camera that's going to own this filter. This camera would be our camera associated with our game object, or in our case here, our main camera in our phaser scene. So as an example, if we're going to apply this controller to a game object, we first want to have a reference to our game object, and then on that game object, we want to pass in our filter camera that's associated with that game object. However, since we're just applying this to our main camera in our scene, we can just reference that camera directly. Finally, with our controller, we just need to add that to our filter on whichever object we're applying this to. So we're going to reference our main cameras, and we want to reference our filters object. And on our filters object, we're going to have two different types of filters. We have our internal and our external filters. Internal, this is going to be applied first to our game object, and then we have external, which gets applied last. So for our PostFX pipelines, we want to use our external filters, and now we want to do our add method to add our new controller, and now we just need to pass in our controller instance. Alright, so if we save, our shader should be applied to our main camera, but it looks like we have an issue. We jump back over to our shader. Yes. So for our fragment shader, when we want to pass in our shader as a string, this should actually be our fourth argument. So we'll want to pass in undefined for our third. And now if we save, our game should reappear and our shader is being applied to our camera. So one thing to note is on our BaseFilterShader, our third argument, this will be our argument if we want to load our shader from our cache. Our fourth argument will be our shader as a string. And that's it. We've now successfully migrated our grayscale shader from phaser 3 to phaser 4. The main things to keep in mind, if we have a PostFX pipeline and we want to migrate this to phaser 4, we need to split our pipeline into two classes. First will be our BaseFilterShader, so our rendering node that gets added to our renderer, and then our controller that gets applied to our game object. And then in our phaser scene, we just need to tell our renderer about our new rendering node, and then we need to create a controller instance and apply that to our filters on our game object. So now for our next example, we're going to work on migrating a shader that creates a wipe effect. For this shader, we're going to look at two new concepts. First, we're going to see how we can pass in uniforms from our phaser scene to our custom shader program, and then we're going to look at how we can load our shader as an external file. So before we start our changes, we'll go into our main.ts file. We're going to add back in our phaser scene. We'll add back in our import. Now we're going to update our game to start our wipe shader scene. When it does, this should break our game. So first, let's move our fragment shader code to an external file. So we're going to copy all of this code here. We'll go into our code base. Under our public folder, under assets, we'll make a new folder. I'm going to call this shader. Make a new file. We're going to call this wipe.frag for our fragment shader. We'll paste in our code. So now we'll come back to our wipe shader. Let's comment this out. So now let's comment out the code for our PostFXPipeline. Let's jump over to our grayscale shader. I'm going to copy our two classes from here. Come back to our wipe shader. Let's paste those in. Let's update our name. So instead of grayscale shader, I'm just going to call this wipe shader. For ID, I'm going to call this wipe. We'll call this wipe shader controller. And we'll pass in wipe here. So on our wipe PostFXPipeline, one of the things we were doing in our class was we were setting a custom uniform called uCutoff. This cutoff uniform was based on a progress value that's associated on this class. So now in phaser 4, to pass in custom uniforms, we need to use the setUpUniforms method. In this method, we're going to receive two arguments. Our first one is going to be our controller, so our wipe shader controller we're creating here, the instance of it, and then we're going to have our drawing context. For our example here, we don't need our drawing context, so I'm going to remove that. So now in our setUpUniforms method, the first thing we need to do is get a reference to our WebGL program manager. Our program manager is new in phaser 4, and this manager is responsible for any shader programs that we're creating. To get a reference to our program manager, we're going to do const, we'll do program manager. We're going to set it equal to this, and then on our BaseFilterShader class, we have a reference to that program manager. So this program manager, this is what allows us to pass those custom uniforms. To do that, we're going to use the setUniform method, and this method expects the key and then the value we want to pass to that uniform. So for our key, we want that to match our uniform that we had before, and now for our value, this can be any value we want. However, if we want a dynamic value, this is where our controller comes into play. So in our setUpUniforms method, we receive an instance of our controller, our instance that we create of this class here. So with that controller instance, we can now reference properties on that class. So we're going to make a new property called progress, And so this is going to match our progress property that we created before. So now we just need to add that property to our controller class here. So to do that, let's add a private property to our class. And now we're going to add a getter and setter. So I'm going to copy these lines of code. We'll paste it. Now our constructor, we'll just set our progress to an initial value of 0. So when our setup uniforms is called, we know our type is going to be our custom controller, so our wipe shader controller. Finally, for our wipe shader, we just need to handle our fragment shader code. So when our fragment shader code is going to be in an external file, we need to have our phaser loader plugin load in that file. When we do this, we're going to give that file a unique name in our cache, and then we need to pass that unique name here inside our constructor. So we're going to remove our fourth argument. Instead of passing undefined here, we need to pass in the string of that cache key. So for our cache key, I'm just going to call that wipe. Now if we jump back over to our phaser scene, let's comment out these lines of code here. And so now to load in our fragment shader code, we need to do that in our preload method of our scene. We're going to do this.load to reference our phaser loader plugin. And now we're going to use the glsl method. And now this method allows us to load that fragment file that we created. So first will be our cache key. This needs to match the key that we provide here, and it needs to be unique. So we're going to call it wipe. And now we need the path to that file. So for our file, this will be under our assets, our shader folder, and we call this wipe.frag. With that last change, all of our code is in place for migrating our PostFXPipeline over to our new shader format in Phaser 4. We just need to update our Phaser scene to use our new rendering node and our custom filter. So to do that, I'm going to jump over to our grayscale shader scene, and I'm going to copy our code that we added before. We're going to paste that in. Now we want to update our references, so instead of our grayscale shader, we're going to do our wipe shader. And then for our shader node, we're going to call it wipe. And now we want our wipe shader controller. Finally, if we save, we shouldn't notice any differences in our scene. Our shader is being applied to our main camera, however, we only notice a difference when our progress value is greater than 0. So if we come into our shader controller, let's update our progress to be 0.5, and now we should see this black bar show up on our screen. So this progress value, this controls how much of our screen gets covered up by our effect. And so how this worked before was we had a phaser tween that would update our PostFXPipeline and update that progress value. So we're going to do the same thing here, but with our controller. So I'm going to copy this code, we're going to paste it, let's uncomment it. And now for our target, we want to reference our controller. So I'm just going to update our controller name, we'll pass that as our target, and now we want to target our progress value on our controller. So we'll set our progress here, and we'll keep our same duration and delay. And now if we save, we'll see our progress value is being updated on our controller, which allows us to have a dynamic value for our uniform we pass to our shader. Here's a quick recap of what we did here. For our wipe shader, we started off by moving our fragment shader code to an external file. When we move our code to an external file, we want to make sure it ends in .frag, and then we need to load in that fragment file in our phaser scene. To load in our fragment file, we need to use our loader plugin and use the glsl method. This method allows us to provide a unique key for our file we cache, and then the path to our file. Then over in our shader code, on our BaseFilterShader, we need to pass in that same name here when we call our super method in our constructor. Internally, Phaser is going to reference that shader code from our cache, and then associate it with our BaseFilterShader here. Next, for our shader, we need to pass in custom uniforms. In Phaser 4, to pass uniforms to our shader program, we need to use our setUpUniforms method. This method will rely on custom values from the controller instance that we create. In Phaser 3, in our PostFXPipeline, this would have been the equivalent of using our onPreRender method, where in that method, we set our custom uniform with our type with our value we want to set. When we want to have a dynamic value for our uniform, we need to make sure that value comes from our controller. For our controller, this will be unique per game object or camera instance, and using that controller, we can modify that value at runtime, which will allow us to have a dynamic effect in our shader. For our last example, we're going to see how we can pass an additional texture to our shader program in Phaser 4. In this example, we're going to pass a noise texture that we're going to mix with our background image in our game. So to start working on our example, let's go into our main.ts file. We're going to add in our Noice Shader scene. We'll update our code to start that scene. And now let's go into our Noice Shader file. So for our Noice Shader, let's start off by moving this into an external file. So under our shader folder, we'll do a new file. I'm going to call this noise.frag. I'm going to copy our fragment shader code. We'll paste that here. So I'm going to comment out our fragment shader. I'm going to jump over to our shader scene. Let's go into our preload method. Let's do this.load.glsl. So now for our cache key, I'm just going to call this noise. Now for our URL, we're going to do our assets, our shader. We'll do noise.frag. Now back over in our shader file, we need to migrate our PostFXPipeline. So on this example here, we set some custom uniforms, and then we're binding that noise texture to our shader program. So now to migrate our code, let's go into our wipe shader file. I'm going to copy our two classes from here. Let's paste that in. We'll start off by updating our class name. For our class name, I'm going to call this Noice Shader. For ID, we'll call it noise. And now for our cache key, this was called noise. So this will give us our fragment shader code. Now for our controller, we'll call this a Noice Shader controller. On our setup uniforms method, we'll update our type reference. And now down on our controller, we want to update our name. So now on our Noice Shader, let's start off by adding in our two uniforms. So we're going to have our uScale and our uBlend. I'm going to copy this, we'll paste it. Let's grab this line of code here. We'll paste it one more time. Let's do our uBlend uniform. And now we need to add these as properties to our controller. So I'm going to copy these lines of code here. We'll replace our progress. Let's copy our getters and setters. We'll replace our progress. Now for our constructor, let's copy these two. We'll set our initial values. So now back up on our shader, we'll update our reference. So on our controller, we want to use our scale property. And for our blend uniform, we'll use our blend property. Finally, we just need to pass our custom texture to our shader program. So how we did this in Phaser 3, when we had a PostFXPipeline, we first had to get a reference to that WebGL texture from our textures manager. We had a few different ways we could do this. One way was we could use our onBoot method and then grab that shader directly. Another way is we could pass that WebGL texture from our Phaser scene to our PostFXPipeline at runtime. That way we could change our texture on the fly. Once we had that WebGL texture, we needed to pass it as a uniform. We would do this by passing it in through one of our texture slots. How this would work was on our onDraw method, we would use our bind texture method. Our bind texture method would allow us to pass that WebGL texture and then specify which texture channel we're going to pass this texture through. By default, Phaser uses channel 0 for the original texture that we're rendering out. Any other textures we want to use, we want to pass that in another channel. So the next available channel would be 1, and so we would pass that texture that way. The other component to this is we needed to set a custom uniform, and on that custom uniform, we need to reference that channel. Once we did this, when Phaser ran our fragment shader code, there would be a new uniform, a sampler 2D uniform, that had our texture that we passed through. So to do this in Phaser 4, we need to get a reference to our WebGL texture inside our controller. So now down in our constructor for our controller, we need to get a reference to our texture manager. We can do this through our camera. So we're going to do this.camera. From our camera, we can reference our Phaser scene. Then we want to grab our scene system manager. Then we do our textures manager. And now we'll use the getFrame method to reference one of our textures we have in our cache. So now for our texture, this needs to reference our image that we previously loaded in inside our Phaser scene. And so our cache key here needs to match that method. And now if that texture is found, it's going to be returned. If it's not found, it'll return undefined. So we're going to store this in a variable. So we're going to do const. We're going to call this Phaser texture. And now we're just going to make sure that it actually exists. If our Phaser texture is not undefined, then we can store this on our property. So right now this is called gradient texture. I'm going to update our name. So we're going to call this noise texture. Let's update our reference here. Now we're going to set it equal to our Phaser texture. And now we want to do our GL texture property. So now this just gets a reference to our WebGL texture. And to use that texture, we need to reference our controller inside our BaseFilterShader here. So to do that, we'll want to add a new getter to our class. So we'll do get. We're going to call this noise texture. I'm going to copy our type from up here. So it's going to be our WebGL texture wrapper or undefined. Now we can do return this and then our noise texture. So now back up in our base filter shader, we need to set our uniform. So I'm going to copy this line of code, we'll paste it. We want to set our noise uniform, and now we need to specify that channel that our texture will belong to. So we want to do channel 1. Finally, we just need to bind our texture to one of our texture slots. How we did that in phaser 3 was on our onDraw method. In phaser 4, we need to use what's called the setUpTextures method. And now this method is going to receive 3 arguments. Our first argument will be our Noice Shader controller. Our second argument is going to be our texture slots or our textures array. And then our third argument will be our drawing context. For our example here, we don't need our drawing context, so we're going to remove it. Now inside our method, we need to bind our texture from our controller to one of our texture slots. So how we do that is we reference our textures array. We want to reference our first channel or our first index in that array. We want to set it equal to our WebGL texture. Now we're going to reference our controller, and we want to do our noise texture property. So for our controller, for our IntelliSense, we're going to update our type here to be our Noice Shader controller. And now the last thing we're going to do is for our noise texture, since this can be undefined, we're going to make sure it's not undefined before we try to set it. So we'll do if our controller, if our noise texture is set, then we want to call our line of code here. With that last change, that wraps up migrating our code from our PostFXPipeline to phaser 4. So I'm going to comment out this block of code here. We'll save, and let's jump over to our phaser scene. So now in our phaser scene, we just need to add our new rendering node to our renderer, create a controller instance, and then pass it to our filters on our camera. To do this, let's jump over to our wipe shader scene. I'm going to copy our blocks of code here. Let's remove our phaser 3 code here. So now we get a reference to our renderer. Let's reference our noise shader. We'll update our node name. We're going to call this noise. Let's create our new controller instance. So this will be our Noice Shader controller. So in this example here, we're going to apply this filter or shader to our main camera. So we want to pass in our controller here. So now if we comment out these 2 lines of code here, we'll make sure our code's working. And once we save, we'll see right away our phaser game shows up, and we can see our custom shader is being applied to our main camera. So if we comment out this line of code here, we should see our base background image. Now if we add back in our filter, we'll see our noise texture is being mixed with our background image. And now to complete our example, we were going to have our uniforms be dynamic, so we'll uncomment these lines of code. And instead of referencing our PostFXPipeline, we just want to reference our controller here. So we're going to want to store our reference to our controller on our class. So we'll add a new private property. I'm just going to call this controller, and I add in our type. So now down here, we'll do this.controller. So now down in our create pane method, instead of referencing our PostFXPipeline, we want to reference our controller that we created. And so what this will do is this is going to update our scale and blend properties inside our shader controller here and bind those values to our tweak pane integration. What that allows us to do is now at runtime, we can modify our uniform values on the fly, and we can see how it affects our shader program that's currently running. So as a quick recap of what we did here is for our noise shader, we needed to pass in an additional texture to our shader program. To pass in that additional texture, we first need to get a reference to our WebGL texture that we want to pass. We get a reference to that texture from our textures manager inside our controller that's associated with our filter. Once we have that WebGL texture, we need to pass it as a uniform to our shader program. To do that, we go into our setUpUniforms method, we provide a unique name for our uniform, and then provide the channel that we're going to put that texture into. To pass the actual WebGL texture to that channel, we need to do that in our setUpTextures method. That method allows us to reference our controller instance that we created and reference our texture slots that will be passed to our shader program. So then all we have to do is on our textures array, we reference that channel, so channel 1 in this example here, and then assign that to our WebGL texture. And so in phaser 3, this would have been the equivalent of using our onDraw and our onPreRender methods. In our onDraw method, we would use the bindTexture method to bind that WebGL texture to our channel, and then in our onPreRender method, we would have bound that channel to one of our uniforms. So a few things to watch out for when you're migrating your shaders from Phaser 3 to Phaser 4 is if you want your uniforms to have dynamic values, we need to manage those with our controller. Our controller, we created a unique instance of this for each of our game objects, and then by modifying the values on that controller, those values will be passed to our shader program. In order to use your filters or shaders with your game objects, you need to make sure you enable filters on your game object. By default, your cameras in your Phaser game, they already have filters enabled. If we want to apply our filter to like an image game object, we would need to use our enable filters method. Once we do that, we can now reference our filters object on that game object. Finally, if you want to load in your shader code as an external file, you just need to use your loader plugin and use the glsl method. And that's it. We've migrated 3 shaders from Phaser 3 to Phaser 4 and explored the new shader workflow. With the beam renderer, shaders are easier to manage and more powerful. Now I'd love to hear from you. What other shader effects should I cover next? Or what other Phaser 4 topics would you like to see covered? Drop your ideas in the comments. If this video helped you out, give it a like and make sure to subscribe so you don't miss the next Phaser tutorial. And if you'd like to support the channel, I've set up a Ko-fi page. The link's in the description. Every coffee helps me keep making these videos for you.